Hello students, I am Vaibhav Chandrakar, Assistant Professor Computer Science Engineering from SSIPMT. As I am taking the subject Design and Analysis of Algorithm, so I am going to start a new chapter today. The name is Branch and Bound Algorithms. Branch and bound algorithms. The name says branch and bound. So here we have to branch and bound. Previously, as we discussed, if we have a big problem P, then for solving it efficiently, we are dividing it in problem P1 and P2. These are sub-problems. This we are doing in divide and conquer technique. But in branch and bound technique, when we branch or divide, then some conditions or bounds are there. These are upper bounds and lower bounds which we require to solve a particular problem. So that's why it is called branch and bound algorithm. The branch and bound algorithms are of three types. First is LIFO branch and bound. And bound. Second is FIFO branch and bound. Third is least cost branch and bound. So we start from LIFO, then FIFO, then least cost, and I differentiate, give the differentiation also of these three type of branch and bounds. As you all studied basic data structures, in that you studied the data structure queue, stack. These you studied. The queue, what that queue is? Queue data structure is like that. In that we are using first in, first out, which is called FIFO. So whenever you are using queue data structure for branch and bound algorithm, so this is called FIFO, first in first out, branch and bound. When you are using stack, then for stack you have this type of data structure. In that you insert different type of data, and every data is inserted or deleted from top only. So for that, which is last inputted is deleted first. So it is called last in first out. LIFO, last in first out. So when you are using stack data structure for branch and bound, then it is called LIFO branch and bound. Third is least cost branch and bound. It is most important, and it is mainly used in branch and bound because it is always calculating the least cost for solving the problem. So I take a normal graph example, and all these three we can solve using that graph problem using these three methods, and get the differentiation of these three. Okay, if we have a graph A, B, C and D, these four nodes are connected, and we have some values 1, 2, 3, 4, 3, like that. Okay, now what we have to do? We have to get the path from A to D, or A to C, C to D, or A to B or D. So for that, what we have to do? We can start from A. So if we are using FIFO branch and bound. So in that condition, what we do, if we start from A, so we can take A. Now whatever the paths are available, A to B, A to D, A to C, A to B, A to D and A to C. So if we store this, in that what we are using, first in first out, so Q we are required. So in that first, which particular node we are selecting, A. Then what are the next nodes, B, C and D, or B, D and C, like that. So B, D and C. So this is first in. So as we selected A and went for B, C, D, so A is deleted from here because it is first input, that is which the algorithm told first in first out, first in first out. So A is deleted. Now next node is B. So A is selected. Now we have to go to B, D and C. As Q we are using, B only we have to select. So we have to select from A to B. But A to B cost is 2 rupees. A to C cost is 1 rupees. A to D cost is 3 rupees. So here we are selecting B, means we are leaving the least cost. So it is the problem. That's why we are not using FIFO branch and bound everywhere. Okay. So this is FIFO branch and bound. Now after this class we will study about LIFO branch and bound.